MAT1033 Final Exam Review Question 32 says solve the systems of equations, and there's three of them, 32, 33, and 34. Problem 32's system has 3x plus y equals 1 and 5x plus 3y equals 7. Now we're not told any specific method to use, so I'm going to use the elimination method, and I'm going to eliminate the y's. So I'm going to target y's for elimination. Now what I want to have in place is a set of opposite coefficients for the y term, so that when I add the two equations, the y term would cancel. In order to have opposites, then this one's 3, that one's positive 1. So if I multiply the top equation by negative 3, then what I would have would be opposite coefficients. I don't need to multiply the second equation by anything to have that as opposites. Okay, so I've got 3x plus y equals 1 and 5x plus 3y equals 7. I'm going to multiply that top equation, both sides, by negative 3, and that's going to give me an equivalent equation for equation 1 of negative 9x minus 3y is equal to negative 3. The second equation didn't change, but if you notice, now when I add the two equations together, I end up with the y terms canceling. Negative 9x plus 5x is negative 4x. That's 0 equals 4. And then x is equal to negative 1. It's half of the solution set. The solution set is an ordered pair where the two lines cross, and the x coordinate of that ordered pair is negative 1. To find y, I would use x equals negative 1 in any equation. So I'll just go with the original first equation. I'm going to plug in a negative 1 for x. That's negative 3 plus y equals 1, and then y is equal to 4. So the ordered pair, negative 1, 4, should be the solution to the system. The way to make sure is to plug that ordered pair into both of the original equations, and if it makes both equations true, that is the solution to the system. The point of intersection. MAT1033 Final Exam Review Question number 33. We're supposed to solve the following system. Doesn't say any particular method to be used, so I can choose the method: substitution, elimination. Graphical method is not such a preferred method, just because it's very difficult unless you have a graphing calculator or technology of some sort to do it for you. Alright, so what have we got? Okay, we've got to, I think I'll use elimination, and I must target either x or y for elimination by adding the equations together. If I add the equations the way they are now, I would still end up with x and y. But if I target, let's just target the x's. And what I need to do is multiply one or both equations by a non-zero factor to obtain opposite coefficients. The least common multiple of 2 and 3 is 6. So if I multiply that top equation, if I multiply the top equation by 3, and then the second equation, let's see, what do I need? I need a 2. Then don't forget the other side. I will end up with an equivalent system of negative 6x plus 12y is equal to 15, and the second equation in that system, 6x minus 12y is equal to 2. Okay, that's multiplying the first equation by 3 and the second equation by 2. Now, when I add the two equations together, add them together, I end up, the x's cancel, x's and the y's cancel, so there's 0 on the left and 17 on the right. That's one of our special systems. So this is either a set of lines that are parallel to each other, which means they do not cross, or it is a set of lines that are exactly the same line. Well, one way that we can tell is take the original two equations and write them in slope-intercept form. So let's solve for y. And we end up in simplest form, y equals 1/2 x plus 5/4. Okay, and that's equation 1. And equation 2, I'm going to do the same thing. I'm curious to see, this is one of our special equations, which one of the special circumstances we have. We either have a set of parallel lines or we have exactly the same line. So if I simplify here, that's 1/2 x minus 1/6. If you notice, slopes are exactly the same, y-intercepts are different, so these lines are parallel. This is a inconsistent system, and there is no solution, which means there is no point of intersection, no solution. Well, parallel lines, there wouldn't be a point of intersection, so we write no solution.